welcome back. Visca the teacher here, and we are going to finish our June 2022 Algebra 2 Regents examination, covering problems 33 through 37, and that would finish up parts 3 and 4. So let's begin. But before we begin, make sure you subscribe. Okay, I'm going to try to post a lot more videos than I have been recently. All right, and knowing your math is going to take you far in your education. Okay, part 3. Answer all 4 questions in this part. Each correct answer will receive 4 credits, or 4 points. Clearly indicate the necessary steps, including appropriate formula, substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For all questions in this part, a correct numerical answer with no work shall receive 1 credit. So if you don't know how to do anything algebraically, still put it in your calculator, write the answer down, and get 1 of the 4 points. Okay. All answers should be written in pen, except graphs and drawings. Those should be done in pencil. Number 33. On the set of axes below, graph y equals f of x and y equals g of x for the given functions. And they give us f of x as x cubed minus 3x squared. And they give us g of x, which is 2x minus 5. And after we do that, we need to state the number of solutions for the equation f of x equal g of x. First of all, when it says state the number of solutions of this, that just means how many times our graphs are going to intersect or touch. How many touches? Okay? It always confuses me when I get a question like this and students can't do it. I mean, you literally are going to put this into y1 and y2 in your graphing calculator. You're going to plot the points and graph them. Okay? We have a 10 by 10 axis in front of us. So what I'm going to do here is I am going to turn on my handy calculator, which you should have, and in y1, I'm going to put the first one, f of x. That's x cubed minus 3x squared. And for y2, I'm going to put g of x. Okay, that's just simply 2x minus 5. Now, I can graph these, and this is what it should look like when it's all done. There is f of x in blue, and here comes g of x in red, just floating on through, ready. There it is. Now, it obviously touches at 3 points. 1, 2, and 3. There's your answer. They are not asking you what the answers are, just how many answers there are, okay? But first we need to plot these. Let's look at our table, okay? Now, I cannot go any further than 10, okay? Which means my x's, okay, this is nice here. I'm going to keep on going. You see these y values that are 20 and 54 here? I can't graph those. I can graph the -4, the 0, the 2, and the -4 here. And I can graph the 9, the 7, the 5, all the way through. So I'm going to grab this window right here. And I'm just going to drag this out here. Now keep in mind, my f of x is blue. So I'm going to color coordinate here. I'm going to graph this one here, -1, -4. I'm going to graph -1, -4. -1, 1, this is -1, 1, 2, 3, 4, right there, big dot. Now I'm going to graph 0, 0, the origin here. I'm going to graph 1, -2, so 1 is -2 is right here. 2, -4, which is going to be right here. And then 3, 0, it comes back here. And 4 goes to 16, so 4 is going to be way up here somewhere. So I'm just going to have the line come like this. Come all the way down up, and then down. Okay, that's my f of x. Okay, now that I've graphed these, I don't need these anymore. G of x is the one in red. These are the y values for my corresponding x's. Okay, so if I know anything, I'm going to start at -5. 1, 2, 3, -5 on the y-axis. And my slope is 2, which means I'm going to go up 2 over 1. Okay, and I am going to just put these dots up 2 over 1, another dot, up 2 over 1, up 2 over 1, and just keep on doing this until I'm, created a line of dots. Boop. Now, I could have followed these, but I would have gotten the same line. That's g of x. Okay, we are not done yet because it still asks us. I'm going to get rid of this table. I'm going to erase some things here. It asks us for the number of solutions. Well, again, the solutions are where my graphs touch. Okay, touch 1, 2, 3 times. It doesn't ask me for where they touch, just how many. 3 solutions. That is 4 points. Putting all this in the calculator and listing the number of times it touches. It's beautiful. All right. Number 34 is the first time this steps up and you're kind of doing some work here. All right. A Foucault pendulum can be used to demonstrate that the Earth rotates. Thank God for that. The time t in seconds that it takes for one swing or period of the pendulum can be modeled by the equation t equals 2 pi times the square root of L over g, where L is the length of the pendulum in meters, and g is the constant 9.81 meters per second squared, a little bit of gravity. The first Foucault pendulum was constructed in 1851 and has a pendulum length of 67 meters. Okay, so I know that L is the length of the pendulum in meters, and I know that they just told me the pendulum length is 67. So I am fairly confident that's my L. All right? To the nearest tenth of a second, determine the time it takes for the pendulum to complete one swing. They're asking me for time. Look at my equation here. They're asking me for time. That's awesome. So all I've got to do is just plug in everything else. So my time is going to equal 2 pi, the square root of L, which is 67. Oh, but it didn't tell us G, did it? It does. It does not tell us in here, this second paragraph, what G is. G is a constant, which means it's always 9.81. So I am just going to put this right in my calculator. Ooh, nice, man. It is a good thing we get this calculator. It is a fantastic thing that we get this calculator. And I'm going to put it in just like we've had it right here. 2. I'm going to use pi. I'm not going to use 3.14. Okay, because I have a pi. Okay, and the square root of a fraction, alpha y equals 67 over 9.81. Okay, 16.402. 402, or excuse me, 420, 367, whatever. Nearest tenth. Tenth, my friends, is one decimal place. 16.4. That 4 will stay a 4 because the number 2 is after it. 16.4, and let's label it. We're solving for time, and time is in seconds up here. There we go. That's not too bad. Okay? But there's another part. All right? And chances are for the second part, we're going to have to still use our equation here. But I got a feeling we're going to have to solve for one of these things. Let's take a look. See what they want. I'm going to get rid of this little screenshot of the calculator there. Get rid of that. Boom. Another Foucault pendulum at the United Nations building takes 9.6 seconds. So they give us T to complete one swing. Determine to the nearest tenth of a meter, it's also one decimal place, the length. So now I need to find L. All right. L was the numerator, and G was the denominator here. So time still equals 2 pi square root of L over G. All right? Now, let me extend this, give us a little bit more space to work with. We know that G is always 9.81. We are solving for L. We have 2 pi here, and they tell us that our time is 9.6 seconds. So I'm going to put 9.6 here. So all I'm going to do is peel away and get the L alone. The first thing I'm going to do is divide both sides by 2 pi. Okay? And we're going to use our nice calculator, and we're going to leave our numbers in the calculator as they are with all the decimals and use them. And we are not going to round until we get a final answer. Okay? So I'm going to take 9.6 and divide it by 2 pi. 9.6 divided by, put that in parentheses because we want to divide by the 2 and the pi. Actually, anytime I use a fraction, or I have a fraction, I really like to use this. That way I don't have to use parentheses. It separates everything nicely for me. Okay? So right now, the left side of my equation is going to be this long number here. I'm going to leave this in the calculator. But for the sake of my paper, I'll just call this 1.5279. Okay? So we have 1.5279 equals, okay, this is bye-bye, the square root of L over 9.81. Okay, now I need to get rid of the square root. So I'm going to do the opposite of that and square. What I do to one side, I have to do to the other. So my square and my square root cancel. I have L over 9.81. But I need to square this. So I'm going to go back to my calculator. And I'm going to square the unrounded answer. Okay? If I just hit the square button, it's going to square my previous answer, which was this. And it's 2.3344, let's call it. But again, we're going to leave this here. Okay? So we've got 2.3344. And thank God we are now on to the final part where we are just going to multiply both sides by 9.81. And multiply this side by 9.81. Now in my calculator, because I haven't rounded a single thing yet, I'm going to take this answer and multiply. See, if I just hit multiplication, it takes this answer. Multiply by 9.81. Boom. 22.900. Okay? 22.900. And oh, I think they wanted me to round to the nearest tenth. Okay, so I'm going to take this, and the 9 will stay a 9 because the number after it is a 0. Okay? So my answer is L is going to be 22.9. Its length. Length should be in meters, so I'm just going to put an M here. There you go. Good. That was a good one. You know, number 35 is going to take a lot longer to read than to actually do. Okay, welcome to Common Core Mathematics, where they make you read a book to answer a question literally about addition and subtraction. All right? Number 35. In order to decrease the percentage of its residents who drive to work, a large city launches a campaign to encourage people to use public transportation instead. Before starting the campaign, The city's Department of Transportation uses census data to estimate that 65% of its residents drive to work. The Department of Transportation conducts a simulation, shown below, run 400 times. That means we have each one of these dots represents one of the simulations. There are 400 dots here. Each dot represents a simulation, okay? Okay, based on the estimate that 65% of each simulation a resident is going to drive to work. Each dot represents a proportion of 200 randomly selected residents. So out of all these 400 dots, I can pick any dot. This one right here, boop. Or this one right here, boop. These dots that I'm clicking represent a 200 group of 200 selected randomly residents who drive to work. Okay? Guess what? None of this is going to end up mattering. How come? Use the simulation results to construct a plausible interval containing the middle 95% of the data and round your answer to the nearest hundredth. In my classroom, whenever they see this, I say that's the money. Okay, that's the money maker right there. What is that? That's my money maker, 95%. 95% represents the mean plus or minus 2 standard deviations. And you might say, oh my God, look at all of this. Where am I going to get all of this information, the mean and standard deviation? Listen, it's right here. It's right here. So that huge long paragraph, okay, you need to take the mean, which is 0.651, and add 2 standard deviations, which is 0.034, and subtract 2 standard deviations. That's going to give you 2 numbers. Those 2 numbers are the interval that contains 95% of the people in this simulation, in this data. Okay? So, let's go to our calculator and take 0.651 and add 2 of our standard deviation. Okay, I'm just doing this right here, which is 0.034, and hit enter. And then I got to do the same thing and subtract 2 standard deviations. So I'm going to go back here and just turn this into a minus. These 2 numbers here is my interval. Okay, so let's just pop this out here. So my interval is going to be, and I got to round to the 100th, which is 2 decimal places, which means this 2, or this 1 will become a 2 because the number after it is bigger than 5. And this 8 will stay the same. So it's from 0.58 to 0.72. That's it. Literally added once and subtracted once. If you want to count the 2 as multiplication, you can. I'm being a little facetious, but that was a long paragraph. All right? Now, you say to me, but Mr. Visca, there's a second part. Okay. The second part says, 1 year after launching the campaign, okay, and there's no math involved here. We're just, we're just comparing stuff. 1 year after launching the campaign, the Department of Transportation conducts a survey of 200 randomly selected residents and finds that 122 of them drive to work. Okay? Should the department conclude that the city's campaign was effective, use statistical evidence from the simulation to explain your answer. Now, I think we'll do one thing mathematically. Out of the 200 that they randomly selected, out of that 200, 122 of them still drive to work. They don't take public transportation. 122. Let's figure out what probability that is. That's our only math we're going to do. Again, we don't need that big, long chart thing. with all those 400 dots. 122 divided by 200. Okay, up 200, not 20. So 200, the decimal will just slide one more place. 0.61. 61% of people, okay, 0.61, still drive to work. So, was their campaign effective? Let me explain something to you. This many people in our interval contains the 95% of people that drive to work, meaning that's normal. 95% is normal. If we have a number that's not in that interval, like if I had 0.8, that's something unusual. That's something that says, wow, look this is a difference we just made. But anything that falls in this interval, we've made no difference whatsoever because it's expected. 95% of people are in, that's why it's called the middle 95%. That's the common occurrence. So 0.61 is absolutely in between these numbers. So they didn't do anything out of the norm. So what we say is no. Okay, should the department conclude the city's campaign was effective? Are more people taking public transportation? No, they're still driving. 0.61%, that's average. That really hasn't changed. It's still common. And how come? What's my reason? Explain, I need to use words. Because 0.61 is in our interval. Now, this was a fancy graph up here. I mean, how upset would you be if you had to actually plot all 400 of these dots and we really didn't even need them, if you were the guy that did this? But that's a fancy chart. I mean, and there are other data that you can pull from charts like this. But for this particular question, we really only needed this information up here. Okay, and then for comparison's sake, we had to compare the sample that they took. And that's it. Number 36, solve the system of equations algebraically. All right, this is going to work out really, really nice because I do these problems beforehand anyways. Okay, I'm going to use substitution, which means what I'm going to do is I'm going to subtract 5 from both sides here. So y is going to equal 2x minus 5, okay? So now anywhere there's a y in this equation, I'm going to substitute in my y value of 2x minus 5. So I have x squared plus, this would have been y squared, right? But in for y, we're going to put 2x minus 5 squared equals 25, all right? Now I've got to FOIL this, okay? I've got to FOIL this. And when I say FOIL, I mean you're going to do like the box method of 2x minus 5 times 2x minus 5. I'm going to do the old school FOIL, okay? So I've got x squared plus 4x squared minus 20x plus 25, okay? This is what you're going to get if you do the box method. Equals, I still have this on the right side of my equation, 25, okay? What makes this really delightful to do, Mr. Visca, no math is delightful. This is a lot easier than it could have been. Is if I subtract 25 from both sides, oh, that goes away, and now it's equal to 0, and I have 1x squared and 4x squared, which is 5x squared. I still have this minus 20x. I don't have this quadratic where I'm going to have something crazy and I got to find two numbers that multiply to one number and add to another. All we're going to be doing is taking out a greatest common factor to solve this. That is the easiest type of factoring there is. Okay, let's take out a 5x. Okay, that will leave me an x in this term and a 4 in that term. That's equal to 0. All right? And what I'm going to do is I'm going to move this. Instead of rewriting it, yeah, I'm getting lazy, right up here. So this part gets right here. All right? Now, look what I can do. Okay? I technically have two factors. I'm just going to T-bone this. I'm going to set each one equal to 0 and solve. Okay? If I divide both sides by 5, my x equals 0. And then I take x minus 4 and set it equal to 0. Well, I'm going to add 4 to both sides, and x equals 4. This is great, but I'm not done. I should have two answers. Each answer should have an x and a y. I only have the x's of both answers. How do I get the y? Well, it's a good thing we have this right here. Y is 2 times whatever x is minus 5. So I've got to substitute both of these values into that equation to find out the y for each one. So if y equals 2x minus 5, what happens if x is 0? Well, y is going to equal 2 times 0, which is 0, minus 5. So y would equal negative 5. So one of my answers is when x is 0, my y is negative 5. Let's try when x is 4. That's y would now equal 2 times 4, which is 8, minus 5, which gives us 3. So my other answer is when x is 4, my y is 3. There you go. You're welcome. And that factoring could have been a nightmare, especially for a 4-point question. But, they took it easy on us. All right, part 6, the last question. Answer the question in this part. Answer the question in this part is the first statement. All right, Bob. A correct answer will receive 6 credits. Okay, this is a 6-point question. Clearly indicate the necessary steps, including appropriate formulas, substitution diagrams, graphs, charts, etc. Utilize the information provided to determine your answer. Note the diagrams are not necessarily drawn to scale. A correct numerical answer with no work will receive 1 credit. All answers should be written in pen unless you're doing some sort of graph or drawing, which should be done in pencil. All right, so let's unveil this bad boy. Boom! Okay, now this is kind of slightly different for a 6-point question. Not difficult, but you really need to understand some basic mathematical setup for equations, okay? Especially when it comes to rates and exponential growth and decay, sort of, all right? 37 says the population in millions of people in the United States can be represented by the recursive formula where A sub 0 represents the population in 1910 and N represents the number of years since 1910. All right? Identify the percentage of annual growth, or excuse me, annual rate of growth from the equation A of N equals 1.015. Hopefully, you can see that if I'm trying to find A of 2, let's say, well, then I put a 2 here. 2 minus 1 is 1. I need to use the previous value. I need to use A of 1 in order to find A of 2. Okay? And what I'm doing to A of 1 is I'm multiplying it times 1.015. So I take my previous number, okay, whatever it is. Okay, if I want the current number, I take the previous number. You don't really need to write this down. I'm just trying to explain it. And multiply it times 1.015. Now what this is the number 1 plus your rate. Okay? So my rate is 0.015. Okay? That would be incorrect the way it's written. And you're saying, what, Visca? No way. Because they want the percentage. This is a decimal. We need to convert it to a percent. I slide it over twice and it would be 1.5%. This is the answer, okay? You should be able to see that right here. You are not required to show the work here. You don't have to show this. I was just explaining how I got it. Okay? If you did have it, it's not wrong, but now you know where that 1.5% came from. Okay. The second question says, write an exponential function, p, where p of t represents the United States population in millions of people, and t is the number of years since 1910. All right, so anytime I write an equation of growth like this, I start out with saying p of t, okay, because they tell me to. It's always my initial or beginning amount. Okay, my beginning amount in 1910, they already told me. Okay, the beginning of A of 0 represents the population in 1910. This is A of 0. This is my beginning amount. All right, I always start with my beginning amount, 92.2. Okay, times 1 plus my rate, which is this right here. Okay, 1.015, and then my time is my exponent, okay? That is the standard form for growth or decay, all right? This is your, I mean, that's your answer. And these videos take probably 30 plus minutes when they could probably take 20 minutes because I explain things. I figure you're watching these not just to get an answer. You can go online and just see general answers without any work to see if you got it right or wrong. But you're here, I'm thinking, because you might need an explanation on some of these things. Okay, this is your beginning amount. Beginning amount. This is 1 plus your rate. Okay, and this is your time, your exponent. And this is your ending or final amount. Okay, right like that. You don't need the blue writing for the answer. You only need the red writing. Red rum, red rum. Boom, 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 boom. There you go. The final piece de la résistance. Okay, I'm going to scroll up a little bit because I got a feeling we're going to need this equation. According to this model, when they say this model, they're talking about this, what you just came up with. According to this model, determine algebraically the number of years it takes. That's time, folks. We're going to find our t. For the population of the United States to be approximately 300 million. So for the ending amount to be 300 million. Okay, so I'm going to put a 300 million in for my ending amount here. And I'm going to put just 300 because these numbers are in millions. That equals 92.2, okay, times 1.015 raised to the t. All right, in order to bring an exponent down, we need to use log or natural log. I just always use natural log. You could use log, but I'm going to use natural log. Okay? Now, in order to do that, though, you just want to keep the base and the exponent alone. So I need to get rid of the 92.2 on the right-hand side. So I'm going to right away divide by 92.2. Divide 300 by 92.2. And just like one of the previous problems we did, or a couple of them, I am going to leave, in fact, just like problem 34, I'm going to leave that number in the calculator, and I'm not going to do any rounding until the end. They want us to round to the nearest year here, okay? So let's get out this calculator. Man, this thing has been really, really super useful. And I'm going to take 300 and divide it by 92.2. Okay, turn this on, clear this out. 300 divided by 92.2. And I'm going to hit enter. Now, for the sake of my paper, I'm just going to write, I don't know, 3.254. Okay, I'm going to round it on my paper. But I'm still going to use this when I calculate it in the calculator. So 3.254. 3.254 now equals the 1.015. point, sorry, that was I got ahead of myself because I was about to write the ln. Honestly, I was. Sometimes I make like little jokes about when I make mistakes. I was going to do something else, but I really was that time. I hope you believe me. All right, here we go. So now I need to bring that exponent down. This is when I bring in ln. What I do to one side, I have to do to the other. So let's just go up here. And now I'm going to rewrite my right side with my exponent coming down. So the left side is still the ln of 3.254 equals t, all right, times ln of 1.015. Okay, notice my exponent came right down. Now at this point, to get the t alone, I've only got to do one thing. I'm going to divide both sides by the ln of 1.015. Boom, boom, gone. T equals. What I do to one side, I have to do to the other, 1.015. So there's no way you could do that without a calculator. All right? So I'm going to take this big number that was in the calculator and take the natural log of it. After I do that, I'm going to divide that number by the ln of 1.015. Let's go. Let's go. So the ln is right next to the number 4. And I'm going to take the ln of this. So all I'm going to do is I'm going to go up and hit enter. That is going to be divided by the ln of 1.015. Bang. There you go. We got 79.243. Okay, 79.243. 79.243. Let's not forget, nearest year. That's a whole number. That will say 79 years. We are done. That was the answer that I came up with when I did this earlier. And it's the answer I have now. It should be. I mean, it's the same math problem. So I tell you what here, people. Give me a like. Give me a like in this dang thing. Okay, I'm doing so much math here. I think I deserve a sticker, a gold star. And the gold star is the ring-a-ding-ding, dinging that bell. And follow me, because I'll be doing more stuff with Algebra 2. I'll be doing more stuff with calculus. All right? Have a good evening. And if you are preparing to take one of these Algebra 2 Regents exams, you got this. And if you still feel a little uncertain, watch a couple of my other problems on these Algebra 2 exams and reviews. All right? Have a good one, everybody. Bye-bye.